This is the practice page for section 11.3 on arcs and chords. In each of these figures, O is the center. Find the measure to the nearest tenth. We typically find the measure to the nearest hundredth, but that's okay. O is the center of this circle. Let's find the distance from Y to Q. Now, we touched on this a little bit in the last video. This segment right here is not a radius, but you could extend it into a radius, and you could extend that radius into a diameter if you wanted to. And we have a diameter and it's going to cross this chord at a right angle. That's what theorem 11.5 tells us. That makes those chords congruent. That chord gets split into two congruent pieces. So this chord up here has a length of 12. Oh, this is actually using a theorem that we haven't even talked about yet. Ha, dang it. Well, let me just explain it to you here. Let me erase some of this so it makes a little more sense. These segments here that have a length of 8, those show you how far each chord is from the center. And if those are the same, then those chords that they're measuring the distance to, they're the same as well. So if this chord has a length of 12, this chord's going to have a length of 12. Now, are they saying that this is 12 and this is 12? Or are they saying the whole thing is 12? I don't know. Kind of confusing. Let's go with those being 12. That makes a right triangle where that's 12 and that's 8. And you want to find the distance from Y to Q. We'll just say it's 12. That's what your Y to Q is right there, 12. Now, if they're telling you that this entire length is 12, then this guy would have been 6. Okay, number 2, we're going to find the measure of arc BC. Arc BC, notice, is going to be congruent to all of these other arcs. I'm just using different colors so you can see that the arcs are different, but they're actually formed with chords that are congruent. So that's your theorem 11.4. If you have congruent chords, then the arcs that correspond to those chords, they're going to be congruent too. So you have 5 different arcs that are actually all congruent to each other. Now, there's no numbers in this problem, so you have to know some things. For example, all 5 of those different colored arcs are going to add up to 360, and they're all the same. So the measure of each one would be 72. We're going to skip down to number 6. We're going to find the distance from A to B. A to B is a chord. Segment PC is a radius. You can extend that into a diameter. Well, to use theorem 11.5, you have to have a diameter and a chord that are perpendicular to each other. And we don't have that there. You need that. And if you had that, you would know those pieces were the same. This red segment right here is 10. This red segment right here is also a radius, so it has to be 10. That means this other piece is 6. Do you see the 6, 8, 10 right triangle? So if that's 8, that's 8. A to B would be 16. Number 7, let's find the distance from A to B. Segment AB is a chord. Segment DC is a diameter. If a diameter crosses a chord, that doesn't really mean anything unless it's perpendicular. So you need this to be perpendicular to go any further. Okay, so if we say that those are perpendicular, then we know those lengths are the same. And we also know that this piece is 3. Follow me through here if you don't understand that. The radius is 5, so the radius also has to be 5 in that situation. 2 plus 3 is 5. Okay, so if you draw your radius this way, do you see the 3, 4, 5 right triangle? That was a really sloppy 5. So that means that length is 4 and that length is 4, so A to B is 8.